This is Jacob Roden. Today I'm going over the static study in CATIA, the static study workbench, kind of going over FEA and FEM and watching how loads and stresses affect a part that you designed. So here we're already in the part design workbench. This is the part that I created here. You can see it's based off the tri-state aluminum I-beam extrusion, number 13344. And I just kind of put all the measures in. So 3 inches wide or tall, 2.5 inches wide. I made this 3 foot long, and then we have the internal corner radius and the thicknesses and everything, and extruded that out. It's a 1060 aluminum alloy already, and then we'll head over here into the static study design. Obviously everything else has been transferred over. Here on the right you can see our assistant. This is just going to kind of lead us through how to do our static study. Obviously I've already put a material in, the 1060 aluminum alloy, so now we need to put in a boundary condition. Now if we go down here to the boundary condition tabs, there's a couple of different options, sliders, hinges, kind of depending on just what it's being used for. So obviously if you have something that's sliding or rolling on something, or a hinge that's being moved around some kind of surface, you can use those. But for this study, we're just going to use the clamp, assuming that maybe this is being bolted down to something perhaps. So we'll select this face as the clamped face, and then select OK. And now, of course, in the assistant, we can see here our boundary condition. This front face is being clamped onto, so it shouldn't move. Now, next, obviously, we have to apply a load. So if we go down here to the loads, we can see pressure, force, remote torque, all that kind of stuff. So we're going to apply pressure on this top face. Then we're going to have to select how much we want. We're just going to say a random number of like 10,000 newtons per meter squared. And then here you can see that we've applied our load. These are the arrows showing where our load's being. So we can assume that this is being clamped on this end, that an even load of 10,000 newtons per meter squared is being applied onto the top face of this. And now we're going to simulate this. So obviously you can press the simulate button down here, or you can find it in results right here, or you can press the hotkey, and it'll take a second to do that simulation. Obviously depending on how complex the part you have is, this could take not long at all. This could take a while, take a couple minutes, and also depending on just your computer hardware. If you have a nice CPU, this might take a while. If you have a not so nice CPU, this might take a really long time. So you can see here your little status windows, preparing simulation, doing all that math for you, activating results. And here we go. Now obviously simulation is completed. We're just going to click close on that, and now we can look at the results. So you can see right here, this is obviously our clamped face. This is our unclamped face. You can see right here the von Mises stress, this kind of gradient from red to yellow to green to light blue to blue, is showing how much deformation we're having. So obviously the farther, or I guess the more red, the more deformation you're having. So you can see that it's deforming overall. It's kind of deforming downwards. You can see that there's a lot of stress up here on this, where it's being clamped, but it's attempting to force it down. But since it's clamped here, it's not being able to do much, so it's applying a lot of stress. Now, there's also a couple of other things you can do. So obviously you can look at the different plots of displacement. So obviously up here it's not being displaced that much compared to down here where it's being displaced a lot. You have your von Mises stress, like I said earlier, where the stress is being applied. It's a little bit less stressful here because it's not clamped. Obviously it's clamped on this side, so it's able to move more, so there's a little bit less stress compared to where it is being stressed up here. Factor of safety, reaction force factor. So you can see where the vectors, these little arrows, are coming off, the reaction force, and then compression, tension, and the little deformation scale that's going on with that, and all very useful tools to be able to see what's going on. view cut, you can make a cut in your part. So if you wanted to see somewhere on here, say you wanted to see, right down the middle here, what the tension was, or right down the middle this way, what the tension was. And here we can put it back to the von Mises stress, and you can see now that we can look at a cross section of that von Mises stress, or obviously whatever other thing we're trying to see. And then you can have a report written out. You can play the animation of it deforming. It's going a little fast. Let's see if we can maybe slow that down. You can reverse it. Go to the end. Have it repeat. Time control speed, so we can turn that speed down a little bit if we need to. So maybe, play it. And then have it do it a little bit quicker. There. And obviously this is all completely customizable, and you can see as that force is being applied how it deforms, where that von Mises stress is, where that stress is being applied all up in here as it kind of reaches down. And you can also, since we made that view cut, you can see obviously there's not much going on since this cut's about halfway down and the stress is really being applied here. But if you had a different type of complex part that you were trying to see where the stresses were being applied, you could see it on this actual cut plane, wherever you put that cut plane. And then obviously you can change, you can look at the values, you can see where they're being applied, you can change the kind of minimum and maximum of the values. So if you're trying to see the von Mises stress, but you want to see it at certain points, you can change where you're seeing them and everything. And thank you for watching. I appreciate your time, and I hope this maybe gave you a little bit of insight into the static study workbench in CATIA. Thank you.